Hello, welcome back to my YouTube channel ADC Maths. In this video, we are going to discuss a very interesting model in the partial differential equation is known as Lagrange's linear equation. Lagrange's linear equation. This is something is interesting, something is a different format because we are not going to discuss the complete integral or simple integral, nothing. We can directly move on to the general. Let us say that the equation is, or the format is, capital P into small p plus capital Q into small q is equal to capital R. So small p and small q, we already know small p and small q are the first order partial derivatives, namely dou z by dou x and dou z by dou y. That's why this comes under first order partial differential equation. Now what about capital P, capital Q, capital R? The capital P, Q, R may be the functions of x, y, z or maybe the constants. So once we will get the PDE in this form, the Lagrange's linear equation format, then there are three steps procedure. The first step is to write the auxiliary equation is the format dx by the coefficient of small p, that is capital P, is equal to dy by the coefficient of q, because what's the q? Dou z by dou y. So that's why I can pick the coefficient of q and put it here, dy by capital Q. Other than these two, the right hand side term is called capital R, so that is dz by capital R. So this is not the fraction, this is not a fraction, this is the ratios. I am going to solve this auxiliary equation by using method of groupings, or sometimes method of multipliers, or even though sometimes the method of the ratios properties. So let us, by using some standard rules in the ratios like a componendo and a dividendo rule, or when we add two ratios and equate in the third ratio, or when we add three ratios and equate in the first ratio, whatever we can do the magical work with the help of the properties of ratios. But our ultimate aim is to get two independent solutions, namely u of x comma y comma z equal to a and v of x comma y comma z equal to some constant b. Once we got these two, then let us move on to the last solution. That's the last step. The required general integral, or is often called as the general solution of the Lagrange's linear equation, is of the format phi of u comma v equal to 0. Phi of u comma v equal to 0. So once again repeat this procedure. First you should write the auxiliary equation dx by capital P is equal to dy by capital Q is equal to dz by capital R. This is the ratios, not the fractions. With the help of the method of grouping or method of multipliers or some other techniques in the properties of ratios to find two distinct, two independent solutions, namely u and v. Then the third step, substitute in the form phi of u comma v equal to 0 model. So that is the required general solution. Thank you.